Hello again and welcome. Hope everybody's staying safe. If you've been watching this channel for a while, you know this Brymen BM869s is my favorite meter of all the handhelds that I've looked at so far. About the only other meter I consider matching its performance is this Fluke 189. Of course, this meter's been obsolete for many years, so if I had to purchase a brand new meter, this would still be my choice today. Of course, I have two of these 869Ss. Brymen had sent me a second one just for testing purposes. On the right I have the EEV Blog 121GW. Again, this meter is made by UEI. Both of these meters have been through quite a few different tests, a lot of them the same. One of the tests I do is I drop test them from a meter onto a 2-inch piece of hardwood. Both these meters have been exposed to that and they did just fine. So one of the tests I do is I expose these meters to different chemicals. I use methanol as well as gasoline. Basically, I want to make sure that it doesn't interact with any of the lettering or the plastics. You can see where I ran that test with this 121GW, and you can see where it's taken off some of the lettering. Some of the meters will actually etch the plastic. Normally I don't see a problem with it except with the cheaper meters. Another test I'll do is I've got a small piezo grill starter, and I'll expose that right to the inputs of the meter, basically to simulate a weak ESD discharge. Again, that grill starter is nothing like what the IEC standard would call for. And again, I've exposed this Brymen BM869s to that multiple times. I've never had a problem with it. Now, when I ran it on this particular meter, it actually damaged it to the point where it threw off the alignment. So something broke down and it started to leak. It's pretty rare that I see that grill starter damage a meter. Again, I've never seen a problem with any of the Brymen meters that I've looked at. Because the grill starter is such a weak spark, one of the things I did is design my own ESD gun, and that's actually based off that IEC standard. And again, I've exposed this meter to that test as well, and no problems at all. I'll also test these meters with a little higher energy source, and basically that's using these transient generators over here. And both these meters have been through that testing. This particular meter had failed at 10,000 volts with a 2 ohm source and a 50 microsecond full width half height. This meter was exposed to the same tests. I don't remember what this one actually had failed at. Again, the grill starter had actually damaged it originally, but I did go on to test it a little higher with that transient generator, and eventually it broke down. So one of the problems with this particular meter, you can see it has this low Z input. Essentially, it has two PTCs that get switched across the inputs when it's in this low Z mode. That switch function is actually part of this rotary switch, and there's no slit in the switch at all. So what ends up happening is it'll actually arc between those two contacts. So if we take this thing apart, you'll see a burn mark now between those two pads where it's broken down. I don't know what would actually happen if you expose this meter to, a real surge test, and then you have it in this low Z state. Assuming that breaks down, my generator doesn't have a lot of energy, but a real generator would. I could imagine that would light this thing up. Now, I never repaired this meter, but I did go back and I repaired this BM869s. And while I was doing that, I thought, let's just try to harden this thing. So this is a board that I made to basically simulate the front end of this 869s. I've got two transistors here that I was testing in hopes of getting this meter up to a higher level. This meter now, the way it sits, has actually been exposed to 14,000 volts peak with a 50 microsecond full width half height and a 2 ohm source impedance, and it survived that just fine. That's on par with the best meters that I've looked at to date. Another thing I'll do with these meters is I'll life cycle the switches. So I do what I call a 50,000 cycle life test on the rotary switch. This is the one that's gone through 50,000 cycles. I want you to just listen to the switch. Again, this one's been through the test. This one is not. Hear how that snaps? This meter has also been through that same test. I want you to listen to the switch on it. This meter used to have a very nice click to it as well. What's happened is it wore all the cam nubs off. So now the detent spring is basically worthless. The other thing that happened with this is we found a lot of metallic dust inside of it. This meter, really nothing. The contacts look pretty good when I tore it all apart. The only thing that we noticed with this is that it cracked one of the contact springs. Outside of that, this meter basically looks brand new in the switch area. So the reason I like the 869S, first of all, it's a split display. I'm used to having more than one display on a meter, so that's a very nice feature for me because, for example, I can display the AC plus DC along with the AC voltage, or I can display like the AC voltage and the frequency, so it makes using the meter a lot more efficient. Another feature I like with this meter is it has AC plus DC. Again, that's just a nicety in that you don't have to measure the DC and AC separate and then do the math. Another thing I like about this meter, it has this high resolution mode. You can see this is 500,000 counts. A lot of people, when this came out, they were claiming that this is a gimmick. I actually use this feature. One of the things I used I was working on a source meter, and I was using this to look at the voltage reference and the input circuitry. It's a high enough resolution where I could actually see the meter that I was working on drift with this. So again, I didn't need a bench meter. I could just do it with this handheld. Another thing I like about this is it has two different K-type thermocouple inputs. And you can see I can select thermocouple 1, thermocouple 2, or have them both displayed, or I can do the difference between the two. You can also display in Fahrenheit or degrees Celsius. Another big selling point to me for this meter, it's just very robust. Again, you look at what this particular meter has been through. Most of the meters that I've looked at would never even be on the bench still to this day. Again, I still use this meter after all that abuse. This meter here, this is really ready for the dumpster. I just didn't have the heart to throw it out because it still powers up. But it's basically shot, and this one here is going to go on to be used for many more years to come. So overall, I really like the meter. You know, it does use a 9-volt battery, so some people complain about the battery life or that it's difficult to come by the 9-volt batteries in their part of the world. One of the more common problems is the short time that the backlight's on. So when you enable the backlight on these meters, it turns on for 15 or 16 seconds is it, and then it shuts off. And there's no way to program that timer. So I get a lot of complaints about that. I thought, you know, I should write Brymen and basically give them some of the feedback that I've heard about this meter. They wrote back and they said, you know, we fixed that backlight and we increased the time up to 256 seconds. So I thought, hey, I would like to make a video where I demonstrate that feature. So can you send me the new firmware for this thing? And they said, well, we can't do that, because basically this has an OTP part in it, or a one-time programmable. So I asked them if it would be possible for them to send me a brand new microcontroller for both meters. And they said that it's possible that by changing that out, it could cause the meter to lose its alignment. So essentially you'd have to have the meter realigned and then recalibrated. And I thought, nah, you know, no big deal. So, and of course I've done a fair bit of soldering in my life. So, you know, changing out a part like that for me, you know, that's nothing really to be too concerned about. So the other day, I get this box in the mail. You can see it's kind of crushed, but sure enough, they sent me 2 microcontrollers for the 2 meters. Now they've told me outright that basically that's a special deal and they're not going to make those controllers available to previous owners of this meter. So this is really just to demonstrate this new feature. Of course, if you're curious why this box is so large, well, it could be that there's a couple of meters inside of here. If you spend any time on the EV blog, you'll know that about a year ago, Dave posted about possibly adding a new meter to his product line. He was trying to get something between the Brymen BM235 and this 121GW. So what we have here is one of Dave's meters. Of course, Dave's meters are going to be blue and they'll have the EV blog logo on them. This particular meter is the final production. It has the exact same circuit board in the back case. This is a different meter's front case, but other than that, it's the real deal. So I've asked Brymen about making a video for this. They didn't have any problems with me showing this thing off in public. They know the way that I abuse these meters, so they know what tests that this thing's going to go through. So as far as I'm concerned, we're going to treat this just like it was any other meter. So for now, we'll put this thing away. Let's have a look at our old Brymen BM869s. You can see that I've started using lithium batteries in these. This one's a EBL. You can see 600 milliamp hours. This meter has a average, I would say, lifetime. It'd be nice if it drew a little less power, but you know, to be honest, I don't change the batteries in it all that often. But I did go to rechargeables with all the meters now. You can see this meter is still in very good condition. There's no cracks on any of the connectors. Again, that's a problem that we saw with the 121 GW. It's not just the prototype meter, but others have seen it with the production meters as well. This meter really, for all the abuse that it's seen, is in really good condition. I'm really not sure where the microcontroller is located. We'll just lift off this top board and have a look. It's probably located under that display. Again, it's been a while since I've had these apart. Have a look at the switch contacts. Again, this is after 50,000 full cycles. Again, for me, a full cycle was rotating it fully clockwise and then fully counterclockwise, and I consider that one cycle. So 50,000 cycles on this particular switch. Oops. I think what I'll do, let's just go ahead and marry this back to the base. I'll just put the old part back into the carrier. We'll just save that for later. Alright, let's have a look here. We'll start, we're just going to add a little bit of solder to the two corner pins. And then we'll go ahead and tack the part on after we get it aligned. So I've gone ahead and soldered down the new part. Next we'll go ahead and clean this up a little bit. Just basically get rid of any of the residue. And before we put that display on, I just want to make really certain that these zebra strips are very clean. Just grab another Q-tip. It's cheaper than spending all the time putting that thing together and then find out it's still not clean enough. Make sure that's snug. Looks good. And we'll go ahead and meet the two boards back together. And we'll reinstall our 4 screws for the switch. Looks like we got everything out of our case. Go ahead and install our board. And we got to install this screw down into the base there. Let's make sure we didn't get any fingerprints on the back side of the lens. Let's make sure we got the switch in the right position, and we can go ahead and marry the two case halves together. Let's go ahead and install our battery real quick, and let's just see if she'll power up. Ha! There you go. VFD volts, DC volt, millivolt, millivolts AC, temp, capacitance. Let's make sure the function switches work. That looks fine. I'd say we're in pretty good shape. Let's just go ahead and button this thing up, and then we'll do a functional test on it. Alright, this should be 2.5 volts at 60 Hertz. Looks pretty good. And this should also be 2.5 at 60 Hertz. Looks fine. It should be 30 Hertz. Looks good. 15 Hertz. That looks fine. 120. Looks good. This should be roughly 70 volts. And let's try it in our DC mode. This should be roughly 60. That looks fine. Let's try AC plus DC. This should be roughly 20 millivolts. That looks fine. This is tried in capacitance mode. We'll go ahead and zero this out. It should be 150 picofarads. That looks dead on. This will be a 1 nanofarad. Spot on. 0.1 microfarad. This always reads, yeah, 101.6. Looks good. Let's try it with a bigger capacitor. This will be a 1 microfarad. Looks spot on. This is 10 microfarads. Looks good. And 100 microfarads. Looks good. No problems there. Let's try it in resistance mode. This will be 1 giga-ohms. So 1 nanosiemens. Boy, it looks spot on. This is a 100 mega ohms, so we should get 10 nanosiemens. Again, spot on. Let's try it with our 40 mega ohms, and we'll just switch this back to resistance. Should be 25 right here. Yeah, it looks good. And resistance 39.9. I'd say that's fairly good. And let's just try it with our 10 mega ohm. Good. Here's a 1 meg. This is a 1% part. Looks good. 100K. Looks good. 10K ohms. It's a 1% part again. That looks good. This is a 1K. 0.1%. Looks good. It's a 100 ohm. 0.01% part. Couldn't ask for anything better than that. It's 50 ohms. 0.01%. Looks good. This is a 1 ohm. 1% part. Looks good. And a 0.5 ohm. 1% part. Looks good. Let's just try it real quick in microamps. This should be 100 microamps. Looks good. This will be a 10 microamp signal. Looks good. Let's just switch this over to DC mode. There you go, 10 microamps. And this will be 1 microamp. Looks fine. Let's just try our upper temperature. This should be like 1040 degrees or so. Well, it looks really good. And let's just try it down. This would be roughly room temperature, or 20, what do we say, 24 degrees, 23.7. Looks really good. Let's try diode check. Yeah, obviously the lead detection works. Let's see here, diode check. So obviously an open. Let's try it with a short. Looks good. This will be a single silicon diode. Looks like 0.6 volts. Looks good. Here's with 2 diodes. 0.123. That looks fine. This is our white LED. So this would be roughly 2.5 volts. So you can see it is lighting our diode. But yeah, you can't read the voltage off of it. So I've just placed these 2 meters in series. Let's just check the milliamp mode really quick. So I just have them attached to our bench power supply. Let's go ahead and turn it up a little bit. And we'll let it settle. Boy, it looks like the two are very close. Let's just take it up a little higher. Looks really good. Those 2 meters are basically dead on with each other. Let's just go ahead and we'll switch it over to the amps mode. And let's let it settle there. Looks really good. Let's go up a little higher. This is about the limit of my bench power supply. Yeah, it looks really good. We can see things are heating up a little bit. So yeah, it looks like no worse for the wear. Of course, the real question is, does the backlight stay on longer. So let's just have a look. So we'll turn these both on together at the same time. Again, the original firmware on the right, this should be roughly 15-16 seconds, and we're expecting, I think they said 256 seconds with the new firmware. Alright, let's go ahead and we'll just activate both backlights, and let's just see how long they stay on for. Again, the original firmware, we're expecting about 15 seconds. There it goes. There you go. So we'll assume that that time was about right. I wasn't paying much attention, but you can go back and look at the video and see how long it was actually on for. Alright, I think that's going to be it for this video. If you've been holding off on buying a Brymen BM869s because of the short backlight timer, it looks like they've addressed it. So good job to Brymen on that one. If you'd like to see Dave's meter in operation, stay tuned. That'll be probably the next video. Another video that I plan on making in the near future. Procured one of the Nano VNA V2 Plus 4. So it's the new 4 gigahertz 4-inch display. But what's nice about it is it has a wider dynamic range than the V2, and it also has more sample points and I think a faster scan rate. Don't quote me on that. So I have not received it yet. I ordered it from Tindy, so I'll probably be benchmarking that against my other network analyzers. Also received additional questions about the low-cost vector network analyzers, so I think I'd like to go over some of that as well. So stay tuned for all that. Stay safe until the next video. Later.